Welcome to a new teardown video. This time it's another scope. Agilent 54621A, fully digital scope, 60 MHz. It's called Megazoom. So, what is that? That has something to do with memory and the way that it interacts with its memory. This is really a nice scope. It is from 1990 something, so it's more than 20 some years old, so it's quite old today. And look at the buttons. They're like really sticky and gross, so they're mostly using channel 1 and sometimes channel 2. And this one is really used a lot. See this one? I just took this off and cleaned it with alcohol. And now it is like new. So this is easy to clean. Just use some alcohol. It's nice and clean. So of course we're gonna clean up everything here, so it's gonna look really nice and shiny. But first, we're gonna see if this blows the fuses. I also cleaned the screen. I was looking for scratches or anything, but look at that. Nobody touched the screen with anything at all. That is nice. I like it. Let's look at the rear. So of course this is a kind of modern digital scope. So that means there's a switch mode supply. And this will support a wide range of voltages, so there's no voltage switches or anything anymore. Just plug it in and you'll be happy. There's also a calibration lock, and this is in protected mode, so that means nobody can screw around with its calibrations, and all that is done in software. Parallel and serial interfaces, and optional interface for all sorts of other fancy things, and you can plug this module in here and lock it into place and put in a screw, so it's nice here. All right, let's power it up. So here's another good trick when you got the buttons off for cleaning. Oops. Of course, also clean the front here around the buttons, so it's all nice. This is probably the cleanest this scope has ever been for 20 years. It's almost like new now. Let's try and do this together. We got input voltage, .44 watts. See, everything here is software. Oh, it's scrolling a lot on the video, but I really don't see this with my eyes. So I'm sorry, this has something to do with the shutter, and I will see if I can fix this somehow. So I'm sorry, I have no way to change this. Ooh, then it goes into what kind of annoying thing is this? So this has something to do with the light, I guess. No, it has something to do with the zoom? What if I turn off this light? Ah, so low light will give it more shutter time. But anyway, we got all the light here. We got single, got the running mode. We got, ooh, this pot meter here is a little bit, oh, this is an encoder. So this encoder is definitely, ooh, look at that. So when I'm turning this, if I move it fast or slow. So this encoder is really not that good. Let's try the other encoder. Oh, they're probably just full of dirt. So that is something we need to address when we open this. Whoa, look at that. Absolutely crazy. And So both of them. This is annoying. This is probably why they were thrown out. And this is the menu button for everything. Let's just try and input a signal and see what happens. Let's try and give this 1 volt peak and hit auto scale. Ha! That is great. I didn't put this into 50 ohms or anything, so obviously it is in 100 millivolts. So it's 1 volt peak. That is into 50 ohm, and this is open, so there's something with the volts. But so far, ooh. So this encoder also needs a little bit of cleaning. See? Okay, encoders. So let's turn off channel 1. Let's put it into channel 2 and see if the auto scale will. Okay, so all the digital stuff seems to be working right. Cursors. Super nice. Ooh, we also got, no, this encoder seems to be alright. And then you click, no, click cursor. Okay, you click. Okay, so, and the other, okay, so this is how it works. Okay, and then it reads out whatever you want to read out. And it's very, very responsive. It's doing everything super nice and smooth. Okay, but this encoder is super duper good. How about this one? Ooh, see? Definitely. But this shows a little bit how fast the digital stuff is. So just there's a little bit of funky stuff with the encoder, and it will just update that fast. It is amazing. Okay, this encoder is also bad. So all encoders probably full of dirt. So that is what we need to look at. But let's open this thing. Teardown time. So I like to put stuff not on the knobs, but on something soft first, so you don't scratch the knobs, and also distribute the weight more evenly on all the knobs and stuff. This is really not so good to have a unit standing on its knobs, but this is really not a heavy unit, so it's alright. A Torx 20, and just those 2 screws, and then the whole shell will be able to be lifted out in one go, I suppose. Yes, they are. Yes, and we are in. So that is the disk drive. I don't know if you got anything that can read normal floppy disk or, well, disks. Oh, some really sexy ICs. Look at that one. Megazoom. Ooh, from Hewlett-Packard. But it says Agilent on the front of this scope, and I think I remember this being one of the very first products with Agilent in the front when they changed the name. And again, we got those really nice plastic sticks and a backup battery. We need to measure that as well. But it's beautiful, beautiful as always. Proper filtering of DC supplies for high-speed memory. Some nasty stuff. Oh, look at that. So this will be the 2 60 megahertz front ends with some relays and stuff going up to, whoa, that it will be the AD converters. And then directly into some custom chips and FPGAs and good stuff. Lots of memory. We even got a timing 200 megahertz crystal for timing. What's this wire doing? Okay, that will be for calibration. So it's just a low frequency square wave. And here is another crystal. 49, so that will be for serial ports and stuff like that. Some normal support. So yes, see? Serial port chip and RS-232 driver. Just some standard stuff. Some more memory chips, a lot of that right there. And let's see the... I need to put it a little bit more safe. So there's a really nice CRT display unit, and so this is the sexy thing about digital scopes. The CRT is now just a really low mo CRT. There's no special requirements for speed and fancy deflection systems and whatnot. And we got a power supply. Okay, so this unit takes some, that's all it takes. Just this flat cable. That is all the screen module takes. And this will be the power supply cable for the entire unit, because this is mains input and there's nothing else in between here. So if we take out the power supply, that is this cable, and we need to get the whole front panel off so we can clean up all the encoders, or probably be dirty or some stuff there. At least we need to take it all apart. It's the only way. So how are we gonna do that? Just love it when stuff is easy. So this is the lower left corner. There's this little plastic flippity flip here, and let's look inside. Here was another plastic locker. Release this and the entire front panel will come off. So that was super easy. It clicks in to those in the top, and then the two flip releases. And see, this metal frame is also the same use for the 4-channel version. Okay, we are in behind the front panel, and of course there is a metal layer, a metal coating on the inside of this plastic. That is a very good idea for shielding. So I took off all the buttons again, so I guess just those screws, and we'll be able to see what is wrong with the encoders. But they are the sealed type. No, those are, oh, those are pot meters, and those are encoders. Ah, they look exactly the same. They're full of dirt. Tick, 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 tick. So that will be encoders. Yeah, but so, yeah, okay. All the blue. That feels, no. They go around and around and around, but there is no clickety click. Maybe there was supposed to be a click feel. Yeah, they're all encoders of some sort. They just don't work anymore. I don't know if you can go in there and clean them, or are they mechanical with sliders, or how we're gonna fix that? But that can't be good. And also I had some problems with those buttons. Didn't really, I needed to push quite hard. So I think we need to clean up here and have a look at that. That was really, really cool. all you have to do is push or slide this board to the right and then bend it up carefully around this end stopper or this locking, and then you'll get this PCB out of its place. Let's see if we can lift this up. This will give us access to all the buttons. So all the push buttons I tried here, they seems to be working pretty good. Here's the rubber thing. So how can that not be working? And again, you see the front panel is the same used for 4-channel versions. And you also see it here. All you have to do is populate the rest of the parts, so it's the same PCB layout. And how about, no, it is a complete different PCB layout for more channels here. So that is not a population thing, but we got space left for more, at least. I think I found the main reason why some of those buttons don't work, especially the ones under the screen. Because see, if we measure like this on each side of the black rubber, so it's quite a lot of kilo ohms when I actually press quite hard. But if I take some of the other buttons over here and I try to do the same, the resistance is a lot lower. Also, see, I don't really need to press that hard. Okay, this is actually the same kind of high resistance, but that will also be one of the channels, or one of the buttons there will be that they used a lot of times, right? This one they never use, and that is a lot lower. Wow, haha. But I think I'll try and clean the gold here with a little bit of alcohol, and I'll try and do the rest the same with this. I don't know how to clean the encoders. They're not really that closed. You can see you can get a lot of dirt in them. But we need to fix this anyway, because they're completely useless the way they work. Without this being fixed, this scope is really useless. Let's look a little bit closer on the encoders. See, it's called 1 to 36 or 1 to 16. So that is how many pulses per revolution. So that is the only two types you got. 1 to 36 and 1 to 16. And all the 16s, they're black, and all the 36, they're blue. So it is that easy. And I think this is a standard we could find. And also, so this is the 16. They go like click, click, click. And those are smooth. So the 36, there's a smooth feeling on those. There isn't any click feeling really. I can feel the contacts moving in there, but it also feels a little bit like it's full of grease. So they go kind of, yeah, I don't know if I can show you guys this, but I need to use quite a lot of force. So what I was thinking about trying to clean up one with really a lot of alcohol and cleaning stuff, and see if I can save one of them. Maybe I should desolder it first, or maybe I can just look if I can buy one. They can't be that expensive, and this should be really easy to find a replacement. I took out the first one. They're real easy to take out. So there's a spacer here on the back, and on the front there's a little metal spacer first, and then a little springy one as well under the nut. So I need to remember that so I can assemble this correctly again. So now I'll go and play with cleanup of this one. So all the encoders are now in after a total clean. Let me see if that's gonna work. I also cleaned all the switch gold contacts, and I also got the opportunity to clean the screen all the way to the edge, and look what I found. April 2000. You often see year or date information on CRTs, so that is pretty cool. I also found one here. It's also 2000. So that is the age, definitely, of this scope. So now I want to assemble all this again and see if it works. Isn't this just beauty? Pling. Now look at this. This damn update refresh rate is driving me nuts. There's no way. Okay, like that. It is just live like you cannot imagine. Really, really nice. And also, see now how smooth. Nice. And there's actually, so if you go fast, it will be more aggressive. So that is how, see? That's how they made the software. So this is absolutely normal and how it works. In the other channel, see, smooth. Time base. Everything is now back to normal after a super clean. And we can call this back into service. All encoders like new. I knew it. So, thank you for watching. Please come back soon. Oops, just picked up another one. Yep, that's how it is. Anyway, the fun thing is this one came with this expansion module, and this is a little bit funny because this says RS-232, and look at that, a 25-pin serial. That is a little bit funny, but then there is also a serial down here. So really, why? Well, you gotta see this fun thing. It looks like this module is compatible with this type of scope, and it was actually mounted here on this scope. But listen guys, this is not compatible. This is definitely not at all for this scope. And look, this connector here is different type, different pitch, different everything. Why didn't they see that? That is so funny. It didn't destroy this connector or anything bad happened, but it's just not right. Yeah, great. So this is the second one I got today, and oops, somebody made service. They changed a transistor in the CRT, and this one is from March 2000 and September 2000, and it is the same with all the dirty buttons and also all the faulty encoders. So this one is also gonna get the cleanup. So this is the analog front end with the shield removed. This is not only a shield, but it's also cooling two important chips. And I think this has something to do with amplification and gain stages and stuff like that. We can't really see what it is, the part numbers, because I don't want to take this away because this is heat transfer. But we got some different relays. And then we got the analog converters. And all the memory and stuff. But I think I already shown all of that earlier in the video. So I'm gonna assemble this and then we're gonna test a little bit. Always remember to measure the voltage on battery backup cells, and this one is perfectly fine. Let's play a little bit with the measurements and how it works and all that. This is the slowest sweep time. So this is 50 seconds per division. That is really, really slow. And as you see here, this sine wave is 4 millihertz, right? The period time is 250 seconds. And this is the quick measure, and it will give you 3 different results at the same time. You can set up whatever you want, and you can go through all sorts of stuff. You can configure for the quick measure. You can clear them and enable them, and yeah, and of course you can have them for both channels. It's a really great the way that it works. All the auto features for time and voltage and stuff is just spot on and really easy to use. And this is the slowest speed. Of course, we can also go to the fastest speed. So let's go to the. So that is 5 nanoseconds per division. So that means we should dial up the frequency. Let's put in. Oh, that was wrong. That was only 1 megahertz. So let's put in 10. See, 10 megahertz is just a half. I wanted to show you 10 megahertz and look at this peak voltage and the readouts and all that. So let's go to the tens. So that's 20, 30, 40. Oops. See, now it's getting a little bit lower. So that was 40 megahertz, 50 and 60. So this is the minus 3 dB point. And it was specified 60 megahertz. So that is perfect. I think it's actually a little bit better than that, right? So that was 60, 70, 80, 90, 100. Far over its specifications. And let's go to 120. So that is double the speed, right? And that is 200 megahertz. Also see, we just need to crank up the voltage a little bit, and then readout is still nice and spot on. But let's find the limit. It says 200 megasamples per second, right? But that is 200 megahertz. So 300. Ooh, it was doing some funky stuff here, right? Let's go to 400. Let's try and play a little bit with the. Oh, here we go. So that was the trigger that was the problem. Okay, here it works again at 400 megahertz, and it's even reading out everything. So let's go down. You see? 200 and so on. So yeah, you can actually measure signals It's quite fast with this good old 60 megahertz scope. You can enable in the utility menu a self-test, and it will go through all sorts of fantastic things with the self-test. I don't understand. I tested everything on this scope, but the self-test ended up with a timing chip test fail. What? Oh, damn it. I just took the other one and ran the self-test, and that one passed the self-test really, really fast. Hey, so there's something wrong with the other one. And also, I can see that self-test runs for a long time and just continue and continue. So what is this timing chip? What the heck is that? One more thing to show about the Megazoom. This is a 10 megahertz signal. I'm running single sweep here, right? Puff. Alright. So this is 2 milliseconds per division. Okay? 1, 500 micro, 200 micro, 100 micro, 50 micro, 20, 10, 5, 2, 1, 500 nano, 200 nano, 100 nano, 50, 20 nano, and that's your 10 megahertz. And it looks beautiful. Look at that. So this is, I mean, Megazoom, yeah. This is really mega zoom. And it's doing it so fast. It is amazing. About the self-test. This one performs self-test, and then it says something about a timing failure. But this is the picture it leaves the self-test, and it reveals that this is 14.34 megahertz. See? And you can also go around the dials here and whatnot. So I think it has something to do with that 14.3 megahertz oscillator that it's not happy about. So now I'm gonna look through if I can find a such oscillator. And of course this scope can play asteroids. Yeah, that is fun. So here it is, the timing chip. So this is the 14 megahertz crystal they're talking about, or it was kind of zoomed in on that last self-test screen. And if I measure the output of that oscillator, it is working just fine. So what the heck is the problem? Of course I also measured the other crystals, they're fine. So that means this timing signal probably go to some other timing chips, or maybe it is that is the timing chip that delivers some timing signals and whatnot. I don't know. Damn it, this one just goes back to the trash then. I know exactly what happened now to this scope. And remember, I previously in this video explained about this expansion module that was punked down in this connector. Those connectors are completely not compatible, and you should of course have seen that. Somebody did not care at all and just punked this one directly down in this one, shorting half of the signals and interchanging signals and whatnot. And all those signals, or of course some of them, go to the chips located down here, right? Including the timing chip. So this is of course responsible for all sorts of lower speed signals in the 14 megahertz range for external I/O, and now some of those signals are of course broken. Yeah, So that means this motherboard is wasted because you can't just replace those chips anyway. Yep, that's how it is.